Okay, chapter 6.1, solving systems of linear equations by graphing. Okay, system of linear equations means there are multiple equations. So linear equations, multiple linear equations. So let's say each linear equation, the graph of each linear equation is a straight line. So when you solve a system of linear equations, that means we are looking for the intersection of the points, intersection of the linear equations, the graph of linear equations. So let's say we have two equations. So one goes like this. The graph of the first line one. So this is the graph of equation one. And let's say another graph is this one. So this is line 2. Okay. Then the solution will be the intersection. So this is the solution. This is the solution. So there is a solution. The coordinate of this point is x. Let's say xy. So these two equations. So system of equation is this. Line 1 and line 2. So here it is equation 1. So let's say x minus y is equal, just an example. Okay, just an example. And then another one is something like 2x minus plus 3y is equal to 5, something like this. So we have an equation 1 and we have another equation. So let's say this is line 1, let's say this is line 2. Then solving this system of equations is the intersection. So since we have an intersection, there is a solution. So, and there's another case. Let's say here is line 1, and here's another line which is parallel. This time line 1, line 2 is parallel. Okay. So is there a intersection? There's no intersection in this case. No intersection, that means there's no solution. So this one has no solution, right? So let me write it, no solution, because there's no intersection. No solution. The first one is, there is a solution. There is a solution, which is the point, the intersection, xy. And the second graph, the second system of linear equations does not have a solution, has no solution. How about this? What if here is one line 1, and here's line 2. But line 1 and line 2 are exactly the same. Line 1, which is equal to line 2, exactly same. Then how many intersections are there? How many intersections? That means, all the points on this line are the solutions, because each point on this line is a solution, right? Solution. Intersection. So all the points on this line are the solutions. So in this case, there are infinitely many solutions. There are infinitely many solutions. Infinitely many solutions. So infinitely, we use the symbol, this infinite symbol. Use the infinite symbol. So if two equations, line 1 and line 2, two equations are exactly the same, identical, then there are infinitely many solutions. And two lines are parallel. So in this case, line 1 is parallel to line 2, then there's no solution. So either two lines are parallel nor are equal, then there is exactly one solution. Okay, so there are three types of system of linear equations. Three types. Okay, this is three types. So type 1, type 2, type 3. Type 3, right? Okay, so we call this type 1. If there is a solution, then we call it consistent system. The system is consistent. So the first type is consistent. So the system is consistent. And the second one, the second one does not have a solution. Then the opposite of consistent is what? Inconsistent. So the system is inconsistent. And the third one, there are infinitely many solutions. So there are solutions. So we call the third type is the system is consistent. Okay, consistent means there is a solution. Okay, consistent, there is a solution. Then we call the system is consistent. All right, how about also we can separate into a dependent system or independent system. So we call a system is dependent if they are exactly the same. The system is dependent. Exactly the same. Two lines are exactly the same. Okay, when do you call two systems? System is not dependent. Okay, we call it when the system is exactly the same. So line 1 is equal to line 2, exactly the same. Then we call it dependent system. And then we call the others independent system. So the first type is the independent system. And the second type is also independent. Okay, can you see the difference? So if there is a solution, is consistent. Solution, there's a solution, consistent. Otherwise, inconsistent. If two lines are exactly the same, it's dependent. Otherwise, it's independent. It's kind of a little bit confused, right? But, the system is consistent if there's a solution. The system is dependent if two lines are equal. All right, in this section, we will solve the system. So we will find the intersection by graphing first. The graphing method is not useful. It's just showing you whether there's a solution or not. Next section is using substitution method. Substitution method is powerful and elimination method is powerful. But this section, solving system of equations by graphing, is not important. But we'll just try to graph equations, and then let's find the intersection as a solution. Okay, example 1 is saying that it's asking whether the given point, -1 and 3, a solution of the following system. Okay, this means if this point is a solution, that means that's the intersection between 2 points. So between intersection between 2 lines, right? So line 1 and line 2. Let's say this is line 1 and line 2. So if -1, 3 is -1, 3 an intersection of these 2 lines. Okay, this means this point is on this line 1, right? Line 1. Also, the same point should be on the line 2. So if a point is on the line, then this point should satisfy each equation, right? So it should satisfy line 1, and let's say this line 1, line 2. Okay, line 1, line 2. Okay, line 1 and line 2. So this point, -1, 3, -1 and 3 should lie on both line 1 and line 2 if this point is a solution. Okay, so let's check. So for the line 1, let's plug in these 2 points, and then let's check whether the equation is true. So x is -1, 3, right? So this is the x value, 3 is the y value. So let's plug it in here. So x is -1 and y is 3, and then let's check whether this is equal to -3. So this is -3 plus 6 is +3, which is not -3, right? So this means the given point is not on the line 1. Is it? Am I doing wrong? I'm sorry. I copied the wrong point. It should be 1 and 3. Sorry, it should be. This is not -1. It's 1 and -3. 1 and negative 3, sorry. 1 and negative 3, 1 and negative 3. Okay, 1 and negative 3. 1 and negative 3. So let's plug in 1 and negative 3 for x and y respectively. So x is 1, y is 2 times negative 3, right? Then this is 3 minus 6, so that is negative 3. Now, they are equal. So negative 3 is equal to negative 3. So we know that this point, 1 and negative 3 lies on the line 1. Okay, let's check line 2. Okay, let's check line 2. Line 2 is x minus 3y is equal to 6. And then x is 1, y is negative 3. So let's check whether this is correct. So 1 plus 6 is 7. Look at this. Y 6, 9, right? 1 plus 9 is equal to 10. So this is not equal to 6. So this means 1 and negative 3 is not on the line 2, right? Not on the line 2. It's not on the line 2. So one of the point is in the line 1, but not on the line 2. So the given point is not a solution. Okay, can you see it? So just plug in the point, and if that point satisfies both equations, then that's the intersection. That's the solution of the system of equations. But if any one of these equations is false, when you substitute the point, then this is not a solution. Okay, let's try next one. All right, so problem 1, same question. Is the given point negative 1 and negative 2 a solution of these linear equations? Okay, so let's say this is line 1. The second equation is line 2. So let's check whether the point satisfies the line 1. Okay, the first equation is 2x minus 5y is equal to 8. And then let's plug in negative 1 and negative 2 for x and y. So this will be the x value, this will be the y value. So 2 times negative 1 minus 5 times negative 2. So let's check whether this is 8. So negative 2 plus 10, then that is 8. So this is equal to 8. So line 1. So this point is on the line 1. Okay, let's check line 2. Okay, line 2 is negative x plus 3y is equal to negative 5. Let's check whether this is true. So negative times negative 1 plus 3 times negative 2. Okay, then positive 1 minus 6 is negative 5. Then this is equal to negative 5. So yes, so line 1 and, okay, so negative 1, negative 2 satisfies both equation. So therefore, negative 1 and negative 2 is a solution. Actually, it's the only solution. That's the only solution. Because there's only one solution, right? All right, this is simple. Okay, let's try and let's keep doing exercise. Okay, example 2. Solve the following system of linear equations by graphing. Okay, graphing. So we will just graph each line. So let's say this is line 1 and this is line 2. So line 1 will be, okay, when you graph a straight line, okay, line 1, line 2 are linear equations. So the graph is straight line. Linear equation because there are two variables x and y, and the exponent of the variable is 1. So this is a linear equation. Okay, when you graph a straight line, what do? We need to find y-intercept, or it is better to find the 2 points. Okay, 2 points. So in this case, let's find x-intercept and the y-intercept of the line 1. So from the line 1, x-intercept. How do you find the x-intercept? we can find the x-intercept by setting the y value 0, no? Y value 0. Okay, if you forget this, set x-intercept, set y is equal to 0, and then find x. Find x. Okay, that's what we do. How we find x-intercept. So set y value equal to 0. So x minus 2 times, what is y? 0, right? 0 is equal to 2. Then x minus 0 equals 2. So that x equals 2, right? So we found x-intercept. X is 2. So the x-intercept is when x equals 2, y is 0. 1, 2, 3, 4. X equals 2, y equals 0. All right, and then let's find the y-intercept. Y-intercept. How do you find the y-intercept? Set x value is equal to 0. So don't forget this. Y-intercept, always set x is equal to 0 and then find y. That's the y-intercept. So from the equation, x equals 0, right? X equals 0. So x equals 0. Minus 2y is equal to 2. We are using line 1. Okay, so from here, negative 2y is equal to 2. Therefore, y is equal to negative 1. Okay, divide each side by negative 2, so negative 1. So when x equals 0, y is negative 1. X equals 0, then y is negative 1. Let's say this is negative 1. Okay, so connect these 2 points. So this is the line 1. Okay, let's find out line 2. Okay, line 2. Okay, also let's find x-intercept first. X-intercept. Set y value equal to 0. Okay, y value is equal to 0. So from the second equation, x plus 0 is equal to 5. This means x equals 5. So we found 5, right? So x is 5, y equals 0. X equals 5. This is 5, y equals 0. Okay, y-intercept. We set x equal to 0 and let's find the y value. So from the second equation, x is 0. Let's find the y value. Then y is equal to 5. So 1, 2, 3, 4, 5. Y is equal to 5. Go all the way to the right. I'm sorry, y-intercept, sorry. Y-intercept is 5. So 0, 5, sorry. 0, 5. So over here, right? Okay. First equation. The second equation is these two. Graphing is not accurate, actually. Not accurate. So where's the intersection? The intersection is over here, right over here. But as you can see this, it's not exact, isn't it? The graph is not exact. So it looks like the x-coordinate is close to this one. So x-coordinate is 4. And the y-coordinate is the y-coordinate 2 or 1? 2 or 1. It's really hard to, place this point because it looks like, between 1 and 2, right? But actually the answer is 1. Okay, 1. So graphing is not accurate. We don't recommend solving system of equation by graphing because, even our graph is correct. If it's not, this is not accurate, unless we graph it, precisely on a grid, line, a grid paper. It is hard to find out to make it an accurate answer. So in this case, the answer is the intersection is this is solution. Intersection is this is the solution, right? And the coordinate is x is 4, y is 1. So once you plug in this one, 4 and 1, for line 1 and line 2 equations, then it should satisfy. So do we have to check this one? Okay, if x equals 4 and 1, because the second equation, 4 plus 1 is 5. That is correct. For the first equation, for x is 4, so 4 minus 2 is 2, right? So yeah, this is correct. So the solution is, therefore, the solution is x is 4 and y equals 1. So when you write a solution, we write it in order pair. Okay, write it in order pair. Write the solution. Write the solution in order pair. We usually write it in order pair. So x comes first and then y comes later. So the input x comes first. Okay, let's try letter B. Letter B is still same. Graph it and then find the intersection. Okay, so when we solve the system of equations, okay, let's say the first is line 1, the second equation is line 2. So from line 1, let's find the x-intercept and the y-intercept. Okay, 4x minus 2y is equal to 6. So from this, let's find x-intercept. Let me use int intercept. So x-intercept is set the y value equal to 0, right? Y value equal to 0. So 4x minus 2 times 0 equals 6. Then 4x is equal to 6. So that this will give us x is equal to 6 over 2, 6 over 4, right? 6 over 4 is 3 halves. Okay, so x is 3 halves. Y equals 0, 3 over 2. Okay, y-intercept. Y-intercept, set the x value is equal to 0. Okay, let me write it here, 3 over 2. When x equals 0, let's find out the y value. So x equals 0, so 4 times 0 minus 2y is equal to 6. So negative 2y is equal to 6. This will give us the y value, negative 3. So negative 3, that's the y-intercept. Okay, that's the line 1. Okay, for line 2. Okay, line 2 is y is equal to 2x minus 3. Okay, in this case, this is in slope-intercept form. So negative 3 is the y-intercept, isn't it? Negative 3 is the y-intercept. So we know what the y-intercept is. So let's find the x-intercept. So set y value equal to 0, and then we will find the x value. So y is equal to 0, 2x minus 3. This gives us 2x is equal to 3, right? Negative 3, move negative 3 to the other side, so positive 3. Can you see it? If you're not sure, then let's try it this way. So I will do a minus 3 each side, plus 3 each side, right? So 3 is equal to 2x. Then divide each side by 2. Then 3 over 2 is equal to x. So this is same as x equals what? 3 over 2, right? So x is 3 over 2. Look at this. The x-intercept of the line 2 is same as the x-intercept of the line 1. It looks like that these two lines are equal, right? Equal, identical. So line 2. Line 2 is, for the line 2, let's find out the y-intercept. Y-intercept. Okay, y-intercept, set the x value equal to 0. X value is equal to 0, right? So x equals 0, then y is equal to 2 times 0 minus 3. So y is equal to negative 3. Okay, so y is negative 3. Look at this. The x-intercept and y-intercept of both the lines are exactly the same. So what is our conclusion? Two lines are identical, right? Dependence. This is dependent system. Two lines are same, right? Okay, let me draw here. This means here's the x-axis. Here is the y-axis. Okay, for the first equation. The x-intercept is 3 halves. This is, let's say this is 1, 2, 3. 3 halves is 1.5. X-intercept. Y-intercept is negative 3. 1, 2, 3. Negative 3. Y-intercept. Two lines are exactly the same. So line 1. This is the line 1, right? And the line 2. Line 2 also has the same x-intercept, y-intercept. So both the lines are same, right? So what's our conclusion? Is there a solution? Yes. How many? Infinitely many. What are they? There are infinitely many. So plug, give one x value, then you get the y value, x value, y value. There are infinitely many solutions. Therefore, since line 1 is equal to line 2, exactly the same, there are infinitely many solutions. There are infinitely many solutions. All right, does it make sense? Okay, let's try our problems. Problem number 2. Okay, problem number 2. Solve the equation by graphing. So A. All right, so let's say the first equation is line 1, line 2. Equation 1 and equation 2. So for the line 1, let's find the x-intercept. Okay, line 1 is x plus 3y equals 3, right? So from here, let's find x-intercept. X-intercept. Set the y value is equal to 0. Okay, y value is equal to 0. So 0 plus, y equals 0, right? So y equals 0. So x plus 3 times 0 is equal to 3. Then from here, x equals 3. So the x-intercept is 3 and 0. How about the y-intercept? Let's find the y-intercept. Y-intercept, we set x equal to 0 and then find the y value. So x equal to 0 plus 3y is equal to 3. So this means 3y is equal to 3, so y is equal to 1. So that's the y-intercept. Okay, for the line 2, let's find out x-intercept and y-intercept. Okay, so x-intercept, how do you find x-intercept? Set the y value equal to 0. Always set the y value equal to 0. So negative x plus 0 is equal to 5. Negative x equals 5. So x is negative 5. Okay, negative 5 is the x-intercept. All right, and then y-intercept. Let's find the y-intercept. Set x value equal to 0. Then you get the y value. Finding the y-intercept, you need to find the y value, right? Y value. Then set the other variable x equal to 0. Okay, so x equals 0, so negative 0 plus y is equal to 5. So from here, y equals to 5. All right, so we found x-intercept, y-intercept for both lines. So graph the line. Okay, y-axis, x-axis. Okay, for the line 1, the x-intercept is 3 and 0. 1, 2, 3. And the y-intercept is 0, 1. Okay, so we can connect these 2 points. So line 1 is this straight line. This is line 1. Okay, line 2. Okay, let's use line 2 of blue color. Okay, for the line 2, the x-intercept is negative 5, 0. So negative 1, negative 2, negative 3, negative 4, negative 5. Okay, this is not accurate. Negative 5 should be a little bit closer to this. Okay, that's the x-intercept. Y-intercept is x equals 0, y is 5. So 1, 2, 3, 4, 5. Okay, connect. Okay, so it looks like this is the intersection, and the intersection is x is negative 3, y is 1, is it 2 or 3? We don't know, right? Maybe it is it 3? Negative 3 and 3. Or 2, is it 2? Is it 2? Is y value 2? It looks like negative 3 and 2, right? Yes. So it looks like the solution is, okay, this is the solution, right? Solution. Then the coordinate is x is negative 3, y is 2. Right, y equals 2, x is negative 3. All right, so let's check if this is correct from line 1. Okay, line 1, plug in negative 3 and negative 2. Maybe, this gotta be true. Then line 1 is x plus 3y is equal to 3, right? So if we plug it in here, then x equals negative 3, y is negative 2. Then this is equal to negative 3. And I'm just checking whether our, the intersection makes these two equations true. So let's check whether this is true. Okay, so x is negative 3 plus y is negative 2. Then this is equal to negative 3 minus 6. Wait a minute. That's negative 9, right? X equals 2. X equals 2. X equals 2. I put wrong number. X equals 2. So x equals 2. Then let's check whether this is 3. Then plus 6. So this is 3, which is equal to 3, right? So this point satisfies line 1. Okay, let's check whether it also satisfies line 2, which is negative x plus 5 is equal to 5. Let's check. So x is negative 3. So negative times negative 3 plus 5y, right? Just y. Then y is 2. Then this is 3 plus 2 is 5. So this is equal to 5. So since the intersection negative 3 and 2 satisfies both the equations, the solution is negative 3 and 2. Okay. Okay, this is letter B. So let's solve the system of equations, line 1 and line 2. So for the line 1, let's find out the x-intercept, y-intercept. Okay, for the x-intercept, we will set the y value equal to 0. So since y is 0, okay, y equals 0, 3x minus 1, then plus 1 each side. So 1 is equal to 3x. Divide each side by 3, so 1 over 3 is equal to x. So x is equal to 1/3, right? So x is 1/3. So we found x-intercept. Okay, let's find the y-intercept. From here, let's find the y-intercept. How do you find the y-intercept? Good. Set the x value equal to 0. X equals 0. So y is equal to x is 0 minus 1. Then y equals 0 minus 1 is y is negative 1. Okay, so that's the y-intercept. And then let's plot this point later after we find all the x-intercept, y-intercept for line 2 as well. Okay, for the line 2. Okay, line 2 is 6x minus 2y is equal to negative 6. So from here, let's find x-intercept. What do? We set y value equal to 0. Y value is equal to 0. So 6x minus 2 times 0 is negative 6. So 6x is equal to negative 6. Divide each side by 6. So x is equal to 1, negative 1. X is equal to negative 1, right? Okay, y-intercept. Let's find the y-intercept. Y-intercept, set the x value equal to 0 and then find the y value from the equation line 2. So x equals 0. So 6 times 0 minus 2y is equal to negative 6. And this is 0 minus 2y is equal to negative 6. Divide each side by negative 2. So y is equal to positive 3. So that's the y-intercept. So let's plot these points on the number line x, the coordinate system. Okay, line 1, this is x-axis, y-axis. Okay, for the line 1, use a red color, line 1. Okay, the x-intercept is 1 over 3. Let's say this is 1, 2, 3. 1 over 3, so it's around over here, right? 1/3. Okay, y-intercept is, x is negative 1. So negative 1, negative 2, negative 3. Like this. Okay, that's the line 1. Okay, this is line 1. Okay, line 2. The x-intercept is negative 1, 0. Negative 1, negative 2, negative 3. So negative 1, 0, x-intercept. And the y-intercept is x equals 0, y equals 3. 1, 2, 3. The graph is not accurate. Not accurate. Look at this. It looks like, two lines are parallel, right? Parallel. How do you know whether two lines are parallel? In this case, it is hard to find the intersection. How do you find the parallel? Okay, it looks like line 1 is parallel to line 2. Okay, let's check. If two lines are parallel, then this means slope, right? Slopes. Slopes are the same, right? Let's check whether the slope of the second line. The slope of the first line is what? 3, right? 3. Okay, so slope of the first line is 3. Okay, let's find the slope of the line 2. We're just checking. Let's check the line 2. What's the line 2? 6x minus 2y. Okay, 6x minus 2y is equal to negative 6. Okay, this is line 2, right? Line 2. So from here, let's find the slope. Slope is, okay, when you find the slope, write in a slope-intercept form. Okay, write in slope-intercept form. So that we can find the slope easily. Okay, two slopes are the same. So move 6x to the other side. So minus 6x each side. Then negative 2y is equal to negative 6x minus 6. And then divide each side by what? Negative 2. Okay. Then y is equal to positive 3x plus 3. So this is the line 2, right? So this one shows that the slope of line 2 is 3, right? 3. And then for the line 1, okay, for line 1 is y equals 3x minus 1. So as you see this, the slope of line 2, the slope of line 1, so the slope of line 1 is 3. So since line 1 and line 2 are the same, slope of the line 2 is same, right? Okay, so since, let me write it down, since slope of the line 1 is equal to slope of line 2, line 1 is parallel to line 2, right? So therefore what? Therefore, there is no solution. There is no solution. Make sense? All right. Once you graph two lines, sketch the graphs of two lines, and in this case, two lines looks parallel, but we never know. So in order to find whether two lines are in parallel, rewrite the equation in slope-intercept form so that we can just check the slopes. So line 1 is already in slope-intercept form, so the slope. So in this case, that's the slope. Okay, slope 1. So from the second line, rewrite the equation in slope-intercept form. So we'll know that this is the slope of the second line. Since both the slope of both lines is equal, two lines are parallel. Two lines are parallel, there's no intersection, so there's no solution. Okay, all right.